Hello, everyone. My name is Radhouane Jrad. I've been in the integration field for more than 2 decades. Seen it all, basically. Got a PhD in integration. I worked in multiple countries and consultancies and whatnot. So this has motivated me consistently to basically share some of the things I've learned throughout my professional and research life on the subject of integration. Over the last 2 or 3 decades, effectively, there has been many patterns, many frameworks, and principles that people created to help us navigate the change in IT spectrum. And I'm sure you would agree with me, this is 2025, you would agree with me, the pace by which the technology changes is increasing. So it's not the speed that is increasing, it's the acceleration that is increasing. And that can be a little bit unsettling, okay? So from an integration point of view, the integration fabric, okay, there have been some particular architectures or architectural patterns that were created and had some good echo. And you build on previous pattern to create new ones, standing on the shoulders of giants. So one of these architectural pattern is the clean architecture, which is about 10-year-old. So we're gonna look at the principles behind the clean architecture, which is not something extremely new. It's effectively a continuation of a couple of previous architectures, if you want. But I'm not going to focus on the technical aspect, the engineering and the code and how you make your code clean architecture compliant. I'm taking it one step above. As an architect who is designing, principles and, who's building the governance for your company or your client, and who is talking to the business, okay? It's a different style when you look at that architecture than when you look at how you're going to make your code compliant with the architecture. So I'm taking it to that one level up, and in my mind, that should be the first thing as an architect to understand and to endorse before getting into the nitty-gritty of the implementation. Okay. Obviously, you wouldn't be talking about IT nowadays without talking about AI. So I'm going to have a little bit of flavor to it later on. But the key thing here in terms of your API landscape and in terms of its interaction with the AIs and whatnot and other systems, how are you going to use the clean architecture to increase the reusability, the maintainability, reduce the costs, and all host of great outcomes. All right, so let's go. Clean architecture. When you, as an architect, when you try to build a landscape for your principles by which you're gonna operate, there are 3 levels for this. There is the what we call the structural principles. These are the principles that you don't negotiate, almost, well, pretty much. These are the ones that have been driving for a good period of time. Domain-driven design, it's a very interesting concept. If the company's business processes are complex, then this one is for you. It's an extremely useful architectural pattern for the integration landscape and the company as a whole. Obviously, API-led architecture, so it's not API-only architecture, it's API-led. So we start, or API first, and then you have other competing or completing architectural patterns and views, things like the events, okay, things like the ETLs, the batch processes, even though it's really should be really something in the history museums, in my mind. Okay, so there is room for batches, but it really should be very limited, and file transfer and all that stuff. Okay, the other thing is security by design. This is very important because we have long moved from adding security to the ready-to-go live product into thinking security as we develop the product. This is very important. It's not a clip-on, it's not a box you tick, and then say done, etc. Nowadays, it's scary. I look at the financial services, the attacks on the current right now on the insurance is scary, you know what I mean? So you have to be not security minded, but it really has to be in the core of the way you do things. And then there is a solid, which is a bunch of 4 principles. We're going to go through them in a meaningful way, but these are very important, singularity of responsibility. So the driving principles are the ones that sort of you can look at them and can you decide how to go, but they are almost structural in nature, okay? So you can see separation of concerns. These are very important. My favorite one is on the right hand, Yagni. You ain't gonna need it. So I almost live and die by this. It's an important state of mind, shall I say, by which you develop reusable, extensible pieces of code or APIs or snippet or whatever. It's very important. The KISS, keep it short and simple, you know, and so on. So these are the principles. You can look at them. You can, you know, research them and Google them, and it gives you an idea how useful they are. And then obviously at the bottom you have the technological baseline that would fulfill those principles. You know, when I say security, I also say login, auditability. You know what I mean? When I say layered architecture, you know, we can think about the authentication. You can think also, is it on-prem, is it cloud, and so on and so forth. There is on the top in the structural principle, there's something we call the head of the snake. So we're going to come back to it later on. Okay, so this is effectively what I operate from as an enterprise integration architect. These are my principles, and this is how I help make the most of the clean architecture and its subsidiary architectures. All right. So now, when you talk clean architecture, you also talk hexagonal and onion architecture. So for the purists, they will argue these are 3 different things, and to some extent they are. But as I said, if you take it one level up, they share a lot of common feature, if you want, or like the purpose, for example. They talk about the core as the business, whatever business thing, if you want, sits in the core, and we need to protect it. This comes from the fact is your bank or your shoe company or your drink company doesn't sell IT. So from that perspective, the business has to have the higher voice in deciding how to operate. The IT comes and enables those things. Sometimes, you know, you have challenges in IT and you need to review the business process, etc. That's fine. But the start point is we're here to serve the business code. And the business code decides, you know, how indirectly, if you want, how the IT will operate to meet those business requirements, if you want. Okay, so the dependency goes from the IT into the core, which can be somehow counterintuitive. Now, the other thing they talk about is effectively you decompose the system into meaningful pieces that you can maintain, you can test, you can scale. You can, you know, the models that you build or the components that you have, they can be reused, you know. So they share these same traits, you know what I mean? And as such, they enable a better improvement to the technology. Because now the technology is not, the business is not dependent on the technology, the other way around. Therefore, you can actually change from technology A to B, at least in theory, to meet a certain purpose in the business, okay? And that's these 3 architectures, they effectively work together to make sure that actually, you know, you don't go into a spaghetti architecture, you know, technical debts. One of the, you know, blasphemy words I hear is a technical debt. Really, technical debt should not be on the table. Simple as that. Technical debt is effectively you delegating your problems to an unknown person. So effectively, most of the time, it becomes a permanent temporary, stiffens the business capabilities, and what the disparate go for a short and cheap way with a technical debt today has a lot of consequences. And we're going to touch that a little bit in the next subsequent slides. Now, if we're going to compare them, and the reason why I compare them, because effectively they are related, at least historically. So the hexagonal architecture was introduced in 2005, and the focus was effectively to put some adapters outside, some connectors, to detach them from the business-related object, if you want, code or application or whatnot. Okay. So the inside is the business logic, and outside are your input and output mechanism. Now, building on the hexagonal architecture, 3 years later, we have the onion architecture. So the onion architecture is almost the same thing. It's an extension, but it makes things a lot simpler. And by essence, it is the beginning of the true implementation of domain-driven design. I'm going to go to DDD later on if you wonder what it is. Now, the third one, obviously, the clean architecture, which comes a few years later. And what it does is effectively, it adds the idea that these things that you build need to be maintainable long term. It has more visionary approach. And the word clean means a lot, because it's a clean a view, clean governance, and clean landscape at all in general. Okay. So effectively, they are, almost the same at a high level. I understand if you go a little bit lower, the implementation might be different, but you can implement the three without actually, breaking the system. Just for the record, domain-driven design came about 2003, but as I said, it's the onion architecture that promoted it really to the mass use. Now, these three architectures have a problem. So I said when I started that actually I want to take it's not basically a level up. But when you read the books and you read the articles about these architectures, you will dive very quickly into the engineering aspect, how you sort out your code, how you do, your comms, the ESBs and all that stuff, But in my mind, you need to apply this at the business architecture level, the holistic view of the integration realm, before you can get to the technical. Because otherwise, you don't have a vision or a view how this is going to impact. So if you sort out, if you put your principles, you make them befitting the onion architecture or the hexagonal architecture, or in this case, the clean architecture, then later on you can clearly request the code to be, written in a particular format or whatever. The other way around is not guaranteed. Okay, you go from general to specific, or from wider to specific, and this same rule, or this problem here, goes against the nature of these architecture, because they say the business core is in the middle, but they go straight to the IT way of doing it. So I think there is sort of a missing link somewhere, and this is why I think we should go at the high level. Now, the other thing is, so this is now from an implementation point of view. You come and you tell people, I want to structure my API arsenal into layers or into this and that. So you can't, instead of having one API that does everything, you need to use 3 APIs, which means you're going to pay a little bit more in terms of licensing and effort. So the projects, they don't like that idea, because you are making them pay more or making them work for longer for something that is not related to the project. It's the product view. So that tussle between product and project is a problem. So it takes a lot of effort, particularly initially, when you set up your environment for a good, clean architecture. You will have challenges from a project. Most of the large companies are project basically driven, so you will find this problem almost in every corporate of any field. Now, the other thing, obviously, these are old. It's not old; it's less than 20 years, but they're old in the new term, if you want. There isn't a lot of AI-related additions done to these architectures. So we're trying to do this today together. Okay. All right. One last thing is, let's say you succeed, champagne cracks, you're happy, you have a good architecture and people are using our principles and everything's fine. complacency is always a real challenge. And the people who bought into what you told them today, they become so comfortable in the clean architecture principles that actually they start challenging them. Okay, so you have to keep an eye on that. So it's always a struggle if you want, even if you get the buy-in and everything works fine. In a cycle of 2 to 3 years, you will find some resistance coming up, and you have to go and basically extinguish the fire. The moment you don't, you let the problem spread, you lose your architectural patterns. It's very hard to fix it. Okay, so the integration fabric, as opposed to say the ERP or CMS, it's in the middle. It's being pushed and pulled all the time. So when it is soundly governed, it works. The moment you lose control, it's very hard to bring it back. You end up living with the legacy things for decades to come. Literally, I have a couple of cases where actually a little change that was not fitting the principles, and that caused a lot of headaches and a lot of money for a good 15 years, literally. All right, so now, if you wanna, if you're a visual person like myself, you wanna look at the three architectures, you can see they look the same. Almost, you have the business inside, and you have other layers. And this is a good, presentation of the three at once. You have the link there, you can go and see it for yourself. But essentially, again, at a high level, you have the business core in the middle, anything business domains, business logic, and then around it, you have the IT governance, the principles, the process, the frameworks, the rules. They fulfill, or they are here to subscribe and to fulfill business requirements. Okay, and it would not be normal that, say, I don't know, table making business, they need to change the way they make their table because of an IT principle. Okay, or even worse, because of an IT code. So we need, from an integration point of view, we need to find the way to fulfill these things. So that's why after that, you get the technology itself. Okay, so you want to be, C#, Java, whatever, and you want the tools, and infrastructure and whatnot. Okay, what these three architecture tell you is the influence goes upwards. Okay, so outwards, sorry, which makes sense. That in turn makes the dependency inwards, and that's why we call it the reverse dependency. So the business is the one that has the highest influence, and then the IT technology has the highest dependency. Okay, so that's on a nutshell the clean architecture and its position with the other architecture. So domain-driven design. I've implemented the DDD for a good, what is it now? 8 years, 9 years? Yeah, something like this. And it just makes sense. And to be honest, sometimes I'm surprised it didn't become a buzzword, because it fits corporates and big companies big time. The logic is very simple. You take a boat, you take a car, you take a house. Let's take an example of the house. You shouldn't upgrade your kitchen when you want to upgrade your kitchen. You shouldn't take out the bed from the master bedroom. They are two different domains, two different corners. They share something, the land, so that's, think of it like an infrastructure or whatever, but they have some sort of dependency. They're not 100% independent. So the pipelines go through. But you can't say, okay, I need to change the bed in the kids' room. Oh, wait, that means we need to change the garage entrance. That doesn't make sense. Same thing with the business. So you have, there are some common, departments. If you want, you have the human resources, you have the marketing, you have the legal team. When you develop, say, for the legal team, there is an integration for the legal team. You shouldn't say to them, let me ask the HR team to do some regression testing. So this is a separation of concerns. Okay, so you will, that's why I said they go straight to the code. So you will want to separate your code per domain, or these domains. But essentially, before you get to the code, you need to design per domain. Your solution has to be clearly domain bound. Okay, and if you design, say, I take the boat here for the kitchen, I need the kitchen to be, small, of the fridge underground, or all the requirements. You shouldn't care about what the captain's view are on the kitchen. Unless he's a kitchen user, if you want, from a kitchen user perspective, of course. But he can say, I can't sit comfortable if you have a fridge, in the kitchen. It doesn't make sense. So we separate these things, so they build them, maintain them separately. This is very important because we're going to apply the clean architecture on this premise, on this principle. Now, let's have a look. So from an actual design architectural view, we had the boats here, but let's have a look from an architecture point of view. So you have a domain A and domain B. If it's a bank, for example, you can say, personal account and corporate account, for example. Or if you're in insurance, you can say policy and claims. Or if you are in the wood production, you can say wood harvesting and wood production. You can do different domains, whatever it is. But you have one same consumer. They need the data from domain A. In this case, we need data about the customer. The customer object is the topic of this example. That's fine. You go to the domain A, you call the API, you're happy, you get the data. But what if you want the data from domain B, from the customer object? And you wonder, say, hang on, why is the customer object in two domains? I'll show you in a second, the next slide, I believe. Okay, so consumer A wants, data from domain A and domain B about the customer object. Now, what if that request to the domain A includes the need to get more data of the customer object from the domain B? Okay, so effectively what I'm saying is I need data from domain B. So, the natural me would say, yeah, just go and grab it from domain B. No, that will make the two domains become bound, and effectively they become one domain. So if you say, for example, you needed to renew a policy. So, okay, that's a policy domain. Take an example of insurance. And then you need to read some data about the claims. So you go to the claim domain. You can't just go and call the claim domain directly. They become one domain, policy and claim. And effectively, when you are updating things, so say you are enhancing the API for the consumer in domain A, you find yourself having to do regression testing and asking people in domain B to test that you didn't break anything. Now multiply that by 100, and you realize actually how chaotic it becomes. And that's the life of a lot of APIs in a lot of companies. You start having versioning, duplicates, and whatnot. Okay, I remember very well, I was in release number 3 of a large modernization effort, and there was an API just about to go live from release 2. And I looked and said, oh, fantastic. So we have this API, we're going to use it. And I was told, this is before it goes live, I was told you cannot use it. Don't even come close to it. And I said, no, I'm not even changing anything. I'm just calling it exactly like you are calling it, in release 2. And they said, nope, you can't. It's so mixed and so many domains and so many that actually they're worried about the performance. If the performance goes bad, how are you going to troubleshoot this? You have multiple departments and whatnot. We had to copy the API, literally. So because I didn't want to rebuild it, I had to copy it. So what do you do then? If this is not a good idea, you go through what we call the gate. Okay, so every domain has a gatekeeping API to be precise. And what that means is effectively, if you need anything from a domain, anything, even if you are another domain, if you are any consumer, when I say consumer, think about systems, ERP system, data management system, whatever, you need to go through the gates. Domain separation is through separation of gates. That way, anything behind the gate is specifically owned by the owners of that domain. So if it is a policy domain and you go through the gate, anything inside the policy domain belongs to the policy team. No one else should care what they are doing in that domain. And they shouldn't care what other teams are doing in their own domain. That's the principle. Some terminology, and I show you the customer object thing if you want. So domain model, there's a list of words and terminologies that you need to probably familiarize yourself with, but these are the key ones. So domain model is effectively describe the domain, like I did with the boat and with the house. The bounded context effectively is how you bound your domain. So the kitchen is, walls are the bounded context of the kitchen. So in terms of say if your bank, personal account is not a company, it's not a corporate account, that's a boundary. You know what I mean? You have to be very clear about the boundaries. And they are business boundaries. These are not technical boundaries. There will be some non-business domains. And the most famous ones are communication, document. But the other ones most of them have to reflect the business domain. You cannot re-domain the business to fit your architecture. Remember the dependency, okay? And then ubiquitous language is very important, okay? And I always use the example of customer, client, party, partner. So for you, they are the same. They mean the same thing. No, they don't. If it's a partner, partner. If it's client, client. So it's very important to use the same terminology across, okay? And, if you call it, if you're building a house and you call it the deck, it's the deck. If you call it veranda, it's veranda. We cannot guess if it's the same or not. That's very important, actually. And then the anti-corruption layer, which is a very fundamental part of the DDD and the clean architecture. So this is a layer that isolates your solution or your landscape from legacy system, third-party systems, other domains. So effectively, the policy domain will work happily without caring about the other systems, even when it needs some data. That's the ACL role to do it, and we're going to see that. So I go back to the customer, and then you understand from a DDD point of view why it's actually a different object for different domains. So in this case, we took the policy and claim example. So a customer and policy domain is about the active policies, the midterm adjustments, historical policies. That's it. In the claims, whichever open claims, historical claims, the discounts and whatnot. Now, I told the party, which is basically client or whatever you call it domain, is where they have the name and address and everything. Who are they? The three together make up the customer, but they reside in three different domains. So if I need policy information, I go to the policy domain. If I need claims information, I go to the claims domain. And if I need the phone number, I go to the party domain. And you can see each domain has its own set of APIs and its own set of DBs, okay, which is slightly mimicking the microservice principle. Now, if we're going to apply this to the integration layer, okay, so effectively on top you have the domain layer, okay, gatekeeping APIs. So it's a lightweight, it's a pass-through effectively, and it's seldom revisioned, which makes it resistant to regression tests. So over the last 5 years, we rolled about 85 APIs. So many projects, crazy. We had 2 regression tests. That's it. And the reason for that, because the code was broke. Because there is a principle, if you go back to the first slide, it's called open-close principle, whereby it's open to change, open to enhancement, closed to change. So the idea is you can add to it as you go, but you should then go back and fix something or change something. Again, Yagni allows that. These are things that I really strongly recommend you familiarize yourself with. So since the domain layer is passed through, you go to the internal layers. You can have one layer, you can have many layers, whatever. But essentially, the internal layers are the ones that mimic the business needs, process, requirements, and whatnot. Because the domain layer is just passed through. Now, you wonder how would you not need regression test in the domain layer? Very simple. Any new request is a new endpoint. So you rather have multiple endpoints, and then when they go inside, you manage them however you want. The consumer will always have a contract with the domain layer. If tomorrow you're changing things in your internal layers, the consumer doesn't care, because it's a contract between your domain layer and internal layer that are changing. Okay, so that allows quick to market enhancement as well. You don't need to say, okay, everybody who's using this API, so I hate versioning in the domain layer. Currently, in the 86 APIs I'm referring to, 85, 86 API, we have one API, one domain layer API that has 3 versions. It's a nightmare, okay? So The reason why we have them is because we were too nice in a sense, if you want. And I'll explain this later in terms of principles. So there is a note about this. But the bottom line is, you have control to the internal resources through the domain layer. So the internal resources, they do the things, again, different names from different architectures, the onion, the hexagonal, but at a high level, they're fairly the same. And then the anti-corruption layer. So that those internal layers, they need data, they need instructions, talking AI here. They need, references, and it's, then you need to call systems. They don't do this directly because they are the business logic mimickers. They mimic the business logic, so they are the core of the part of the business core. Instead, they rely on the anti-corruption layer, the ACL, to go and fetch that data, to go and send that data, to do anything with the outside world, okay? And it's not a 3-layered architecture, it's an N-layered architecture. I put the internal layers in one. And just to be clear, no one owns this. It's been around for decades. I know some technologies, they endorse it like if it is theirs, but it is not. But they're doing a good job in using it. Now, obviously, as I said, the anti-corruption layer, they use adapters, ports, connectors. Depends on which of the 3 technologies you use different language. Again, it's a bit simplified, but that's the idea. When you build your solution, you have to isolate your APIs, your internal APIs, through a domain layer APIs and the anti-corruption layer APIs. And I'm going to show you an example now. But bear in mind, remember the influence and the dependency again. So because it's the middle is the core, the mimicker of the business. So the dependency is towards that core. Okay, so we are consistent in that sense. You want to apply the domains. So effectively, each domain will have its N-layered architecture separately from the others. Let me clean up this a little bit so you can see it better. Here we go. So effectively, we have multiple domains with N layers in each domain. And the domains that don't talk to each other, they go through the domain layer of each. Okay? Now, let's have a look here. So you have a domain A, and you have system of records, whatever they are, database system, whatever. And then you have your layers. In this case, the abstract layer is probably subdomain. So you have multiple subdomains within the domain. That's fine. Let's say you have the domain layer. It's an API that only passes through to say to the abstract layer APIs. And these APIs, they need some data. So they go to the ACL and say, can you please get me data, or can you send data, or whatever. Okay. So this is the principle. Now, if you're not in a layered architecture mode, all these can be 1 or 2 APIs, but you cannot reuse them. So these APIs, each one of these is a champion in what it does, and can be called by multiple. You can see here, one API calling 2, and you can see some examples of many APIs calling 1, etc. So this is the style of thinking before we get to the code. Now let's say you bring the domain D to it. Okay, so it's a domain D, and hey, I need to call something from domain D. As I said, you go through the gatekeeping API, you go through the domain layer, and then you go down and you get your data. Now again, somebody would say, why can't I just call directly? You will bind the 2 domains and you make them 1 domain. So if we have an arrow from the ACL of domain A and domain B direct, that means you can do nothing in domain B without asking domain A to check, to do regression testing. That stiffens your code and your speed of delivery, or your ultra, because this is fast after a little while, but your ultra speed, because the quickest way to deliver is to do point-to-point integration. But point-to-point integration, where it leads. That's why we had SO, that's why we have API, that's why we have AI. It's because it doesn't work. It stiffens the system in no time. Before it used to be 5 years. Now, basically, to see the impact, nowadays is different. I'm going to talk about this. So you see the dependency, etc. Now, you can apply this to the entire company without doing much if your integration is already clean architecture compliant and DDD compliant. So what does that mean? You can call an event hub. You can call a workflow, business workflow. You can call an ETL engine. You can call an agent. We talk about agentic API here. When you do this, you can effectively, so you can call them up and down. But by the way, I said domain layer is lightweight. So this arrow is coming from the domain layer. They are passed through. They will always have to be passed through. If they are not, then they will have to go through. They have to come from the ACL. okay? But effectively what you do here, you are making these systems part of your domain. So you organize the companies or the organization domains without having to move them. Of course, you can call a bucket outside the domain, because this is not a physical separation, it's a logical separation. If you go through your APIs, that bucket there becomes specific to domain A, if you want. Now, if the company decides not to use them as a domain, or you can have some buckets within, some topics within the domain A, some not, that's fine. But the idea is you can extend the domain-driven design with little effort, okay? Now, this is the API, and this is I would have stopped here, don't know, 7 years ago. There you go. You do this one, you're a winner. You can have multiple APIs. Just to give you some statistic, we doubled our integration in the last 3 years. We reduced the cost. So if you put the principles properly, governance, everything proper at the high level, and then before you go to the code, then you're in for a good win eventually. And that eventuality is not 5 or 10 years anymore. But now we have the AI, so we need to keep an eye on this. And this is one of the things I am looking at implementing. I'm looking at right now. I'm quite, enthusiastic about what the AI brings to the table, particularly agentic AI. It's good tool. ChatGPT is a great tool, and Copilot and whatnot. But from a business process point of view, the agentic AI seems to be more interesting. So historically, for those who don't know, we had predictive AI, which is basically, think of it like the weather forecast. And then you have the generative AI, which is basically Copilot or ChatGPT. And then the agentic AI is gaining momentum. So the generative AI does things, the agentic AI makes decisions. So think of it like the agentic AI is the brain. It can think, it can call, it can decide, but it does nothing. While the generative AI, it can do things, and I'm sure you know that through ChatGPT and Pilot, but it doesn't think, doesn't decide if it should call this API or that API. So the combination of two, from an AI point of view, is fantastic. From a company, from an organization point of view, you're more likely, in my opinion, you're more likely to go into the agentic AI use than generative AI, depending on the domain. So generative AI, you hear a lot about how they're good in documents. Whatever is related to documents, they're very good at it. Okay, but if you look at, I'm going to cover this. You look at the advice, if you want, or the practices, or you will see that actually you have to treat the generative AI, in almost the dumb way. Okay, and that's problematic. Okay, the agentic AI is effectively, it will decide if it should go with, the exchange rate from here or from there, based on the situation, the context. This is how useful it is, and we're going to cover that. Now, another one, the MML, is effectively we move from one model effectively to multiple models. So when you combine agentic AI, for example, with the generative AI, you have effectively multi-model learning situations. You know what I mean? So what is a model? I mean, just a simple definition. It's effectively it's a function, if you want, that generates outputs based on the inputs. Okay, you give instructions to generative AI. It gives you artifacts. It gives you a picture. It gives you a text. You give an instruction to agentic AI. It gives you decisions. You know what I mean? From that perspective. All right. So the MCP, this is quite interesting, because the MCP, before the MCP, I think it's the next point. Yeah, there we go. Before the MCP, everything was hard-coded point to point. So the MCP came to basically to allow reusability, allow the agents, allow AI to work together, AI functions, if you want, to work together. Think of it as the integration layer inside the agentic AI landscape. Okay, so instead of calling things with a hard code, you go to the MCP, and MCP will call it for you. It's similar. It's an integration principle in a sense. And then with all this came the prompt engineering, which is basically engineering development for AI. Okay, There are tools out there, probably I shouldn't name them, but they are specific to AI, and they add to your skills. This is very important. A lot of people worry about the redundancy of their skills. No. If you're good in Java, if you're good in Python, if you're good in C#, you still have to be good at them. Okay, you still have APIs to be developed. And even if your AI develops your API, you still have APIs to be reviewed. Okay, so your knowledge is not going to go anywhere. The only thing you add to, just like decades ago, this is my take on it. Decades ago, we used to open a notepad, write a HTML tag, HTML and /HTML here. Then basic tools came and we learned that, and we moved on from that. We don't do it anymore. Okay, so your skill of building web page, for example, is not lost. Your skill of writing HTML is lost, if you get my point. Now, as we are now, as of today, September 2025, there is not clear definitive classification of the prompt engineering techniques. To be honest, even the definitions, the high-level definition is easy, but as soon as you get into nitty-gritty, it gets a bit loose. So there is more ground to be broken here before we can say we are ready with a full foul-proof prompt engineering. Okay, right. Now, how am I designing for a clean architecture, DDD bound, with AI in mind? It is really that simple. I can make it complicated, so I sound sophisticated, but it is not. You have consumers to your layers. One of them would be an AI agent. You call in, you go into a system of records to get data. You can also send instruction to an agent. Okay, so it's just an extra layer. Some consumers will still come directly to you via API endpoints, and some will just have their own agent. What I mean? And remember, inside your integration, you will still have AI as well. Okay, so you can if you look at the tools that a lot of companies offer, they now have the option to bring an agentic AI function in it, say to check the weather or to check the address or whatever. So there is a lot of interesting, stuff that you would do inside the integration layer, and these agents will be owned, if you want, by the domains. Okay, but also you will fulfill, requests from agents from other consumers. They're just external consumers coming through the domain layer, or you're going to go to these agents that people made available, other systems made available for you. Okay, if you don't control these AI agents, you're almost guaranteed you're going to get what we call agent sprawl, which is basically what we have in the API world for ungoverned or ill-governed APIs. So it's very important to manage these agents. How? The domain-driven design allows you to do this. Okay. Now, there are already many architectural patterns that actually AI-centric or AI-friendly, and we'll go through them very quickly. But from a domain, sorry, I go a bit fast. Here we go. So from a domain perspective, domain-driven design perspective, the bounded context make the agents as powerful in their own domain as the APIs are, and you can manage them easily. So the agents that deal with the policy, they don't also deal with the claims. The agents that deal with, chopping wood processes, they don't also deal with, legal actions. So you separate the concern and you manage it. Obviously, you don't want to have 100, agents per domain, but still within the domain, you can have feature-rich agents. So now this is what we go into the agentic service mesh world, where the APIs and the agents can communicate seamlessly. And this is why we need to separate the concerns. This is why we have the bounded context, because otherwise the mess of the APIs and the mess of AIs will come together. And right, so we go back to this. So I'm going to go a bit quickly here. Effectively, the agent becomes a domain champion, domain expert, and your agents will reflect your business goals and will make sense from a human point of view. You know, you can't say, go and get me the policy number and renew the claims. It reflects what? A combination of goals. So you need to separate that. Okay, and obviously using the ubiquitous language means basically developers from different, you know, different domains that still speak the same language and they can exchange data and whatnot. Okay. As I said, you know, so we protect against the agent sprawl and reduce the cost. This is the elephant in the room, and that elephant is growing. Okay. The cost, the way AI is being built is changing, and changing in a weird way. So initially, you know, how many agents, then we move to transaction-based, and now we move into the value-based. So, I mean, if you produce a document, you pay me for the agent. If you send send an instruction for email, you pay me. So it seems like we're going into the territory where, because you're using my agent, I'm going to get a cut of your business. And of course, if your business is doing good, you still have to pay me the minimum. So the cost of agents is going to be quite important, just like the cost of, you know, API calls and, you know, workers and instantiation of whatever product you use. And it will be very hard to reconcile your agents once you threw them into the production realm. So you're gonna be really hit very hard. And the billing is still being switched on. So all this free stuff that they put in there, somebody's gonna pay for that. So the best way to do this is to keep governance, to keep it tight. Okay, I mean, and there's a lot of documents, there are a lot of, you know, papers on this. But the key thing is you can't just say, you know, agent for you, agent for you, agent for you, Oprah style. Okay. Now, there are 6 principles when it comes to agentic AI integration in the clean architecture world and the DDD. So zero trust security, that's the domain layer for you. Reliability, performance and scalability, again, bounded context, champions of what they do. Operational efficiency, as I said, they reflect the business. They are DD compliant. And these nice pictures or these figures that I shared with you, diagrams, they have no name against them. So if you want to have an API from a different vendor, even though that's something I usually always say, don't mix technologies for the same purpose. But it's probably that boat has shipped by now. Many companies have multiple products. But even then, so you can, when you put them all within the same domain, you know, you have an operational efficiency in that sense. Reusability. So the agent that goes and say checks the weather is going to be reused by, so it's the weather domain, and every other domain, you know, say marine planning, you know, you're going to plan how the boat's going to operate. You need the weather, you're going to go to the weather domain and ask for data. The same request will be taken from the lorry domain, whatever, you know what I mean? So reusability is quite high. And affordability, TCO. This is the thing. At the moment, the AI is not thinking about the TCO. They're thinking about the POC, the proof of concepts, go live, you know, impress everybody claps, yeah, okay. And then we will find out that the cost is a lot higher than anticipated. This is the same story of APIs and microservices repeating itself. Okay, so this is when I come with the layered agentic service mesh, LASM. Effectively, you have the integration platform, agents and APIs can call each other. So remember, you know, the AIs it's layered, the APIs it's layered just by you know, it's layered architecture, and then you have a separate domain. Each can talk to systems and databases through the ACL. It's fine. So it's an infinite loop, if you want, between agentic AI and APIs calling each other. So an API calls an API, that's within the API layer, and then calls an agent, it goes to the agent AI layer, and so on and so forth. Okay. As I said, they are structured around layered architecture, but they're also separated by domain. I cannot put enough emphasis. If they are all within the same domain, this flexibility will disappear in no time. Okay, so just a reminder here, each API layer comes here in this picture is consistent of a set of n-layered APIs, domain layer, etc., etc. Okay, and the same thing, each API layer consists of a set of agents organized in a specific pattern. Now, the agentic AI pattern is not the same as the API pattern. obviously. So I mentioned a couple of AI-centric architectural patterns. So you have the orchestrator worker, which is basically there is one agent that gives instructions to multiple agents, or you have basically the hierarchical, where each agent calls the next one and then calls the bottom one, etc., and so on and so forth. They share the blackboard, which basically they go to the same source to get the data that they need to do, and so on. There are plenty of them. Okay, and you know, for the same domain data for a domain-specific data, say customer object, the data for the customer object in that particular domain, and the agent has to be different between the domains. So the agent that pulls customer data in the policy domain, and the agent that pulls customer data in claim domain, like it must be different. Or simplifying the tasks, it has to pull data, but whatever you develop for that agent, they have to be different. So sometimes it might sound that you're duplicating, but you're not. The objects are different. Okay, and that enhances the reusability as we discussed. Okay, now the orchestration can be done within the API. So think of it like you have an API that calls an agent and then does next thing and does the next thing and then call another agent and so on. That's an orchestration per API. You can have the agent, the agentic AI, call another agent, can call an API, call another agent, call an API. So the orchestration within the AI layer. Okay, and they have a combination of both. Okay, if it's none, means it's single call to single call. Okay, so you need to make sure that all these go through the gate or gatekeeping, of the domain when you apply these things, and they would work the treat. We cannot forget about the queues and the topics. In case of events, you can use these events as part of your domain layer. This is an important statement from a DDD perspective. You can call the API, or you can throw a message into the queue of that API in the domain layer, and that API is listening to the queue, pulls it, and push it through. And that makes it more extensible. Same thing with events and what. Okay, the key thing is always separation between of the core layer, within a domain layer on the top and ACL on the bottom. Okay. Now, this is new territory, if you want, in a sense. It's quite new in September 2025. So you have an API, you have an agentic AI. That's not API. I need to fix that. So that's an agentic AI calling an API to get data. And in this case, in this example here, you can see we get an exchange rate. So the agentic AI calls the MCP layer. So you don't have to hard code it, which calls an external API. In this case, exchange rate.nst. And then the MCP layer then parses the results back to agentic AI. So you can see the agentic AI has used an API. Okay. Now, the opposite is actually even more recent in a sense. So there is a lot of work to be done here. Effectively, an API instructs an agent to do something. In this case, get address. So you can see here on the right hand, call external API. If you open that box, you will see layered architecture. You call the domain layer API, which goes there inside and checks if it needs orchestration or whatever, and then returns the data. On the left-hand side, we open that box for the agent. You can see you have 3 agents here. So the planner, remember the orchestration type architecture we just mentioned a few slides ago. So the planner takes the call and then goes and asks the retriever agent to retrieve. And the formatter agent will basically format the output. So this is an example how the APIs call the AI. And before AI, you would have to develop code and that application behind the API to do these things. So it's quite powerful on both sides when you put a layered perspective and domain-bounded approach to the combination of AI API. We are working on this. I mean, it's not a final status by any means, but it's definitely, from a principle point of view, it's definitely stable. And as I said at the beginning, you start with the high level principle, and then you go down, and then you apply those findings, and then you fine tune. So this is again one of the principles in the first slide. If you go back, you will find effectively, it's a feedback-based, iterative approach. It's not a design and go. Right. So I'm going to give you some random notes about the topic. I just want to reduce this my vision. So microservices, 15 years ago, 10 years ago, they were the best thing on earth after slice grid. Now it's a problem. If you have too granular microservices, that means one agent is going to make 1 million calls. So it's going to get a lot of load, and there is more chances to fail. You know what I mean? So suddenly, mesoservices are better than microservices to some extent. Mesoservices are effectively regrouped microservices in a meaningful vessel. And I wrote an article about this, and basically they share the data set, so to reduce the load. But in principle, it's quite a challenge. Events. So the order of events and debugging capabilities become quite complicated with AI. If the API is called, you can see the code, you can see who's calling, you can put some debugging feature, but then you have AI coming and making a decision on the fly. Did the AI make the decision, or is it the integration coming from API? The level of complexity increases a lot. Okay, that's a challenge. And then the API, this is very important. So the API, you have to move from schema-based to also become intent-driven. So when you call an agent, agentic AI, when you call it an agent, you need to use more of an intent than a schema. Okay, so if you use, say, generative AI, you have to describe what you want. If you give an instruction to an agent, you have to tell them exactly what you want. And you give them the context. Think of them like almost like a human. Okay, and then you have to decide who's doing the orchestration. You have to understand and know who's doing the orchestration. That's really important. So remember the Agile Manifesto. Still, you need some documentation. It's not zero documentation. Okay, and if you call an agent, suddenly, the get, as you can see, the get has to have more significance from a business point of view. We used to make the get customer profile, get payment history. Now we're going to ask the agent to give us both. That means nothing for the agent. You're going to tell them, can you give me the discount? How much should I give me the discount? And then they will go and get the customer profile and payment history and still this guy deserves 10% or 50%. Okay, so there is a change in the mindset. Again, you see, building up, we still have the schema need, okay, but it's just also need to have the intent need, okay? So are we going to rewrite APIs? Of course not. And it's impossible, it's costly, and it's probably not a good idea either, even if you have the money for it, okay? You use the principles, the common principles, the ones I shared in the beginning, to make sure that your armada of AIs and APIs is well governed, okay? So again, the agents are either consumers or special systems of record when you deal with them outside the integration. Within the integration, you have to make sure that they're domain bound and layered as well. Okay. One more thing. So you probably heard of this 70-30 rule. 70% of the tasks are with the human, and 30 70 are with the system, and 30 with human. To be honest, this is probably like 5 years ago or 3 years ago. I don't know, to be honest, if it's 70-30 or 30-70 or etc. Some aspects, some companies really laid off customer service and marketing and stuff like this, and I mean, you don't know, probably in a year's time they will hire them back. This reminds me of the business process re-engineering back in the 70s, I think, when they thought they could replace humans with machines. So we don't know. I mean, that's probably a guess or a thumb in the air statement. But the idea is you should push more work to the agents than to humans. Okay. So these tips, you find them even on OpenAI pages. You know what I mean? Don't tell the AI what not to do. Keep that in mind. Tell it only what to do. Be specific. I need 3 top answers or 3 top values, not a few values, okay? Ask for it, make sure that the output is in a structured way so you can use it, JSON format. So you can, example here, whatever it is, .NET or whatever. And then you have to get the why before the what. Okay, that's funny, because it seems to me we're dealing with the baby, with the kid here. Don't tell it what not to do. Because if you go to a kid, you tell him, whatever you do, don't touch that. Guess what? They're going to go and touch it. Or we tell them, what did you do? They say no. Well, let's say yes. Why? They're going to justify why, it take a lot for them to say, sorry, got it wrong. So it is, AI, from an integration point of view, at least, or from an IT point of view, you have to dumb down. You have to describe everything to the nitty-gritty so they do things. And I remember somebody said, the only thing I want from, again, from generative AI is it writes faster than me. Okay, agentic AIs are promising smarter, the brains. So if that turns out to be what it is, and it looks like it's going to be like what it is, then you can actually use the generative AI in a much better way, right? Now I'm going to finish this slide with some, my personal experience. Obviously I have gray hair here, so it comes with good stories and bad stories. You have to understand, as an architect, you're not a solution designer. You're more than that. Solution designer is probably going to be replaced by AI. That's another reason why not to be one. So you connect the business engineer. You have to understand the business side of everything you're dealing with. So you can't just go and you say, these are the domains, these are the, this is the business requirement, I'm going to do it. No. Even the why behind the business requirement. Very important. And, this leads to the question, are you a business architect or a technical architect? And it's a problem. So most of us would come from a technical background, usually developers, and then they become architects. What happens then, they become slave to that technology or to that principle that they use all their life. You got to detach from that. On the other hand, those who come from, say, information systems, they are very good at, the business level. They can, design these things, but they struggle giving you use cases because they haven't had their hands dirty in a sense. So, that's a challenge. But at the end of the day, you got to be close to the business one way or the other. That's the core of the clean architecture, okay? If an engineer, if a developer does a mistake, you test it, it fails most of the time. If you design wrongfully or you ill-design, usually it's too late. Now, I made a comment. It used to be 5 years to 10 years to see the mistake from an architect. Nowadays, within a year or two, okay? So here's something, if you know an architectural pattern, if it works for you, don't use like a hammer in everything, the nails, the glass, the teeth, whatever. No, gotta be open-minded. So you cannot be stuck in the same architecture pattern. You can mix and match when it makes sense. What that means also, don't get emotionally attached to your artifact. This is a very, very important aspect of the life of an architect. You have this idea, you have this big picture, beautiful picture, and you feel like it's no longer relevant or half of it needs to be wiped, and then you resist that because you're emotionally attached to that artifact. Whatever you produced, a code, what presentation, that is a big mistake because you will be stuck behind. And then what these type of architects end up doing, end up basically slowing down the change, putting the stick in the wheel because they're worried, to lose those artifacts. I made a fantastic, solution, but they didn't take it. No, don't be attached emotionally to it. If it means you need to drop it, just drop it. All right. Now, from another perspective, when we talk about DDD and clean architecture, the start point, you have to start as a purist. No exceptions. This is how it works. And then, the reality will hit you, and then you start, adjusting it. That's fine. If you start loose, you can't gather it into meaningful governance after that. Okay. So I acknowledge there will be reality to it, but you start from a purist point of view, and you say, fine, if this, or now you cannot do this, and so on and so forth. Principles in IT and in life are very easy to implement until they become unhelpful. Okay, so you're tight in budget and time, and you want to go live. You start cutting corners. Yeah, that's when you throw in your principles away, and you live long enough to see the consequence of that. Okay, so the idea here is, you're either a long-term strategist, you have an eye about the 5 years, the 10 years. So you build your principles towards that. or you just focus short term, I don't care, to hell with everything else. That's fine. I mean, if you know, if you're in a you know, what's the name, you know, in an enforcer team, get in here to fix this and get out, that's fine. But you can't be both. It can be a little bit of one, but you cannot be 50-50. I'm a strategist and a short term. It essentially doesn't work. And most often you go towards the short term. You end up more of a short term. Okay. The quick and dirty. I have a long story about history. Sorry about the liquidity. So it's something that, you know, you run out of time, you run out of budget, whatever. And instead of thinking carefully, because you don't have to do technical debts. There are ways, there are technical solutions. You have to plan for these things, and you manage your artifacts, your objects, your assets with that tactical and the final you know, state in mind. You know, it's very different to having technical debt to say, we will look at it later. Okay, so what happens here, it's expensive today, it's exorbitant, you know, later. And that later, again, it's 6 months, 1 year. I just give you the example of APIs haven't gone live yet, and they're already legacy. Can touch them, can use them. Okay, project versus TCO. As an architect, I need to keep the total cost of ownership in mind. So licensing, yeah, sure, this is cheaper now. What about, you know, many times you find out about licensing when you get the invoice at the end of the year, you're already using that product, it's too late. And one of the things I always say, it's very hard to get rid of an integration system application. They're like the veins in your blood. Once you go with this vendor, there are some like success stories, but usually it doesn't work. Now, I mentioned the head of the snake. So this is a statement. From an integration point of view, this doesn't apply to other aspects of the business. They're different. From an integration point of view, the head of the snake should be internal to the company. So that means you are accountable for the governance, for the strategy, for the TOC. If you use external resources for these ones, they can be helpful, they can be supporting. There is an expertise there that you can delve into. But the accountability and the decision making from an architectural point of view has to be internal for better outcome. What happens if it's not? When architects change, governance is lost. You know, when architects get it wrong, they will be dispatched elsewhere and you have a new one and we don't know what happened, so on and so forth. So that's a very key important, and I mentioned many times before, the head of snake for integration team has to be internal. Okay, they are only accountable to the company they are working for. Okay, now the reverse pyramid versus engaged disengaged. So this is one of the last things. So effectively, if the developer didn't do a good job, let me put it in simple terms. How many developers don't want to do a good job? 1%, 1 per 1,000. So if a developer doesn't do a good job, means they didn't get the right information, the right tool, or the right support. So that's the reverse pyramid. Actually, the engineer is at the top of the pyramid. The architect was not clear. The tools are not working. The business requirements were not properly translated into integration requirement. So you have that engineer has to be engaged from the beginning. There is no, here is what you need to do by engage, disengage. That style doesn't work in DDD. It's very important that the engineer can talk to the business. Okay, and that's empowers them. That makes them stay in the business. We have a very high retention rate because our developers and engineers, they are very much pseudo architects. And then they are the people who will tell you, this is wrong, because they're close to the engine. The mechanics know a lot better than the owner of the mechanic shop because they are right next to the engine. They tell this engine needs this and that. Okay, so that's something to consider. There you go. I hope I shared some new stuff with you and summarized a few other stuff. I hope it motivates you to dig deeper into APIs and AI and then the mutual enrichment that we are embarking on. Okay, and hopefully in the next presentation, I will tell you about the outcomes of my own. Thank you very much. I hope you enjoyed.